Good morning, students. We are studying NCERT Class 8 Math Part 1, Chapter number 4, Quadrilaterals. Today is 12 August 2026. In the previous class, we have studied about the rectangles and some of its properties. In today's class also, we will study about the rectangles and some more properties of the rectangle. Let's have a revision of what we have studied in our previous class. We have seen an example that a carpenter is having a stick. He is having two sticks, each of having equal length of 8 centimeter, and he want to place one stick over another, and he want to draw a perfect rectangle by using the corners of the by using the end points of the sticks. See, a carpenter is having two sticks, each of having 8 centimeter length, and he want to put one stick over another, and he want to make a perfect rectangle by using the end points of the sticks. Understood? If this is the stick AB and this is the stick CD, this is AB and this is CD, and he want to place this stick over this stick in such a manner that it become a perfect rectangle. And we have seen how the process, how he has found that what is the perfect way of placing the one stick over another to make a perfect rectangle. For that we have deduced the three points we have deduced. What was the first point? The first point was that if we draw a rectangle, if we draw a rectangle having one stick as a diagonal, and we complete the rectangle, and we make join simply the other, and we see what is the similarity between this stick and this stick. And we have, by using the property of the congruent triangle, we concluded that the length of AB and CD are equal. Understood? In first point, what we have concluded that AB is equal to CD. Understood? In the next point, what we have deduced that if this is the point of intersection, this is the point of intersection, then how these are related. We have seen that in that case we found that AO is equal to OB and CO is equal to OD. It means O is the midpoint of AB and O is the midpoint of CD. Understood? This we have concluded in the second point. For the detail how we have deduced and how we have come to this conclusion, that you can see in my previous video of this chapter. And what the third point we have deduced, the third point was that the angle formed by these two diagonals, how they are related. The angle formed by these two diagonals, how they are related. Understood? And from that conclusion we find out that all these sides are actually equal. We find out that In the third conclusion, we come to know that AO is equal to OB is equal to CO is equal to OD. Understood? And what we have concluded that O bisect the AD and BD in such a way that all the lengths are equal. Means AO is equal to OB equal to CO equal to OD. This was our third conclusion. So we have come to the end point that what is the solution of the carpenter's problem is that he has to place this stick over this stick in such a way that the midpoint of this and midpoint of this, he has to place the midpoint of this stick over midpoint of this stick, and when he places the midpoint of this stick, midpoint of AB stick over the midpoint of the CD stick, and after that the figure will come, he will just simply join the end points of the stick, and that will become a perfect rectangle. Means if this is AB and this is the midpoint of AB, we place the another stick over here, which stick is CD. Understood? This stick is CD. Now since this is the midpoint of both sticks and they are equal, only we have to join the end points of the stick, we will get the perfect rectangle. And this angle can be any angle. In all cases we will get the perfect rectangle. Means if this is our stick A, B, and this is the midpoint, and you can place at any angle the another stick which has the midpoint over this stick. Understood? And you join simply the end points of the stick, you will get the perfect rectangle. In this way you will find a perfect rectangle. In the real world you can construct a perfect rectangle not only on paper but in the real world. Like if you are making a wall, or if you are making some floor, or if you are making some another construction where you require a perfect rectangle. Understood? This is one of the way that you will get the perfect rectangle. So this was the problem and the solution of the carpenter. Now we will move ahead in the chapter. What the next chapter says? See, from the study of the previous classes, what we have studied about the rectangle, that rectangle is a quadrilateral. Understood? Rectangle is a quadrilateral having opposite side equal. Understood? And all internal angles are 90 degree. All internal Understood? And in this class, what more we studied about the rectangle? That the diagonals of rectangle bisect each other. Diagonals of rectangle bisect each other means if these are the diagonals, the point of intersection is bisecting the diagonals, means this is equal to this is equal to this, and all these are equal. Understood? The diagonals, and what more, and the diagonals are equal. Also this point included in this, and actually we have to write this first. Diagonals are equal and bisect each other. We correct it. Diagonals of rectangle are equal. Understood? Diagonals are equal and bisect each other. What does it mean? When the diagonals are equal, then after bisecting, means after dividing the diagonals in half, then all the parts are also equal. This is understood. Understood? So this is the additional information which we have concluded from this chapter. And what more information we have concluded? That okay, the fourth information about the rectangle we will see, and then we will study here, and we will include in this list. What is the fourth property about the rectangle? See, we have seen that opposite sides of the rectangle are equal, right? We have seen that opposite sides of the rectangle are equal, and we have seen that diagonals are equal and they bisect each other. Or also we have seen that the internal angles are 90-degree. This is what we have seen. Now we will see the relation that this point is A, B, C and D. We will see what is the relation between A and B. We know that A and B is equal. Now we are checking this in other terms, that whether these are parallel or not. Understood? What we are going to check? That the opposite sides are parallel or not. That we will see. Now see, in this triangle we will see that you know the property of parallel line and the transversal. If these two lines are parallel and one line is just intersecting the other lines, understood, then internal angles, these are the internal angles of the same side, the sum of the internal angles are 180. Understood? Sum of internal angles of transversal line with parallel lines are equal 180. Understood? We are talking about these angles, this angle 1 and angle 2. These are 180. Understood? Now see, if we take AB and DC and we see this internal angle and this internal angle, what we come to know? That we come to know that angle BAD is equal to 90 degree. Understood? And angle ADC is 90 degree. Now these two angles are 90 degree and their sum is angle BAD plus angle ADC equal to 90 plus 90, that is 180 degree. Now we come to this conclusion that these are the two lines and these internal angles, the sum is 180 degree. It means that the reverse of this conclusion, that the sum of the internal angle are in parallel line when the transversal line is intersecting, the internal angles are 180 degree. It is always, this is the fact and you can prove, we can prove, and we have already proved in the previous class. So when these sum is 90 degree means these two lines are definitely parallel, means when this angle and this angle is 90 degree means this line and this line is definitely parallel. We have concluded that AB is parallel to BC. Understood? AB is parallel to BC. In the same way, when we will see AD and BC, understood? The same way we can prove that AD and BC, they are also parallel. Why? See, when we see AD and BC, the internal angle is this one and internal angle is this one. When we take together, this is also 90, this is also 90 and their sum is 180, which gives which tells us that AD and BC is also parallel. Understood? AD is parallel to BC. What we have written here, AB is parallel to DC. This is my mistake. AB is parallel to DC and AD is parallel to DC. What it concludes that the opposite sides of the rectangles are equal as well as the opposite sides of the rectangle are parallel. This is our fourth point. This is what we have learned new, that in rectangle opposite sides are parallel, and we can write another point here only, and equal. Understood? So opposite sides are parallel and opposite sides are equal. Now we will see a very unique case of rectangle. We have said that in a rectangle, rectangle is a quadrilateral. In a rectangle, opposite sides are parallel and equal. Understood? We are talking about the opposite sides are parallel and equal. So is there a case when all the sides are equal? See, a rectangle, there is a rectangle, understood, and this angle is 90 degree, this angle is 90 degree, this angle is 90 degree, this angle is 90 degree. We have seen. Also the diagonal, this diagonal and this diagonal, these are also equal in this rectangle, and also this side A, B, C, D. Also we have seen that AB is parallel to DC and AD is parallel to BC. Understood? This is also in this figure, and what we have also about the diagonal, that AC is equal to BD. Understood? We have all the properties of a rectangle in this diagram. In addition to that, we have one more property or one more feature of this figure, that what is that? That AB is equal to BC is equal to CD is equal to DA. Means this is also equal, this is means this is equal to this, and this is equal to this also. All these are equal. In that case, is it a rectangle? Definitely, because all the properties of the rectangle this diagram is having. In addition to that, all the sides are also equal, and we know about this particular figure when all the sides are equal and when all the internal angles are 90 degree. So this is the special case of rectangle, and we call this figure square. Understood? When in a rectangle, when your opposite sides are equal and your opposite sides are parallel, as well as your all the sides are equal, it means that particular rectangle is a square. So this is a very special case of rectangle, that figure is a square when all the sides are equal. So we can conclude that all the squares are rectangle, but we cannot say that all the rectangles are square. Understood? So this you have to understand, that rectangle is a part of, sorry, square is a part of rectangle. Understood? Means all the rectangles you have also squares. We have already studied some information about the Venn diagrams. Understood? What is Venn diagram? Venn diagram means we are representing a set of elements through a diagram. So if we say that this is a circle, this is a figure which is representing all the squares, if this figure is representing all the squares and this figure is representing all the rectangles. So how this figure and this figure, when we combinedly draw, will come out as, this figure will come out as the bigger rectangle is the bigger figure. This will be like here, and the square figure will be inside this. Understood? So it means that all the squares are inside the rectangle. Means all the, but this part, all the rectangles are not square. So in this way, through the Venn diagram, we will represent like this. Understood? And we can also say that if we take the quadrilateral as a universal set, so what is the Venn diagram of the universal set? See, we represent a universal set by a rectangle. If this is the universal set of quadrilaterals. Understood? Universal set of if this is the universal set of quadrilateral and this is the set of rectangle. Understood? This is the set of rectangle, so square will be the part of rectangle. Understood? How you name it? You can name it that this is rectangle and this is square. In this way, in the universal set of quadrilateral, this is our rectangle, this is our square, and we will study some more types of quadrilaterals, like we are studying here about the rectangle and square. Then we will see how those quadrilaterals, specific type of quadrilaterals, are in this universal Venn diagram, that we will also see as our chapter progress. See, that was our fourth deduction. What was our fourth deduction? That what is the shape of the quadrilateral will all the angles equal to 90 degree. We will study this topic. This is in our book. What is the shape of quadrilateral when all the angles are equal to 90 degree? All the angles are equal to 90 degree. Now see, we have given a figure which is a quadrilateral. Understood? Which is a quadrilateral. I am not talking about rectangle or square. This is a quadrilateral, and we have given a figure, and what this is showing that this angle is, all the internal angles are 90 degree. Understood? This is given to us. Now simply join. Understood? Now this, so say this angle is 1, this angle is 2, this angle is 3, this angle is 4, and let's name it A, B, C, D. What we conclude that angle 3 is equal to angle 1 and angle 4 is equal to angle 2. How we conclude that? It's a very we have already done in the previous part of this chapter, that angle 1 plus angle 4 is 90 degree and angle 3 plus angle 4 is 90 degree, and from these two equations we conclude that angle 1 is equal to angle 3, and in the same way we also conclude that angle 2 is equal to angle 4. Understood? So this conclude that what does this conclude that, and the sum of these angle is also 90 degree. Understood? This is also no. So what this conclude that? This conclude that uh, when the quadrilateral is having all the angles 90 degree, then it is a rectangle. This is our conclusion. Then it is a rectangle, means by corresponding part of congruent triangle, means we say that if in triangle ABC and triangle ACD, we conclude that AB is equal to DC. Understood? And in the same way, when we see the opposite triangle, we conclude that what we conclude that BC is equal to AD, and also we see the internal angles, the sum is 180 degree, means they are parallel. So we conclude that this is a rectangle figure. This is a rectangle figure. Understood? By doing this process, we conclude that the question is what? Deduction. What is the deduction for? Deduction 4 is that what is the shape of the quadrilateral when all the angular angles are equal to 90 degree? The answer is the figure is rectangle. Understood? The answer is figure is rectangle that we have proved here. Let's see what is the next topic. Now see, the next topic is that we have seen the special case of rectangle. Special case of rectangle is a square. Now we will see the about the diagonals of the square. Understood? What special thing we can conclude about the diagonals of a square? This is the special case of rectangle in which all sides are equal. Understood? In which all sides are equal and this figure is satisfying all the properties of rectangle. In addition to that, this is also include that all the sides are equal. So we will see what is the nature of the diagonals AC and BD, that we will see here. See, from the property of rectangle, we already know that if this is the point of intersection, that AO, DO, OC and OB, they are intersecting each other, they are bisecting each other, and the length is equal. Means AO equal to DO equal to CO equal to OB. This we know. What we will conclude that about this angle. What is this? Is this angle is any specific angle in case of when the figure all the sides are equal? Now see in this diagram, this is the same diagram. We are taking A, B, C, D and this is point of intersection. We are taking the triangle. In triangle AOB and triangle BOC, what we see that AO is equal to OC. AO is equal to OC, we know by the property of rectangle. OB is common. OB is equal to OB and AB is equal to BC. This is given that all the sides are equal. AB is equal to BC. What we conclude that the both triangles are congruent triangle, means triangle AOP is congruent triangle ABC. By corresponding part of the congruent triangle, we conclude that if we name this as 1, if we name this angle as 2, we conclude that angle 1 is equal to angle 2. This is what we have concluded from the congruent property. Angle 1 is equal to angle 2 by corresponding part of congruent triangles, CPCT. And also we know that AC is a straight line and this line is intersecting AC. So the complete angle is 180 degree. Means angle 1 plus angle 2 is 180 degree. And from 1 and 2 we conclude that angle 1 is equal to angle 2 is equal to 90 degree. So what is the special case which we have seen here? That when all the sides of the rectangle are equal, when all the sides of the rectangle are equal, diagonals intersect each other at an angle of 90 degree. Understood? This is 90 degree, this is 90 degree, this is 90 degree, this is 90 degree. So this is our conclusion. This is our fourth deduction. Sorry, this is our fifth deduction. What is our fifth deduction? I will write here. When all the sides of we are talking about rectangle are equal, it is given. Understood? Then diagonals intersect or bisect, we can include both, because since we are talking about the rectangle, means intersection is actually bisecting. Understood? So the diagonal bisects each other. Diagonals bisect each other at an angle of 90 degree. Understood? This is our fifth deduction, that when a rectangle is having all sides are equal, in that special case, with the diagonals bisect each other at an angle 90 degree. Understood? Always. And this is the case of the square, means uh, the diagonals of the square bisect at 90 degree. So this is our fifth deduction, and this is all for today's class. In next class we will see the other topics of this chapter. Till then, revise this chapter and take care yourself. Thank you very much.